the zeros, and I'm going to name the polynomial function for you. I'm going to ask you to find the zeros. Guys, this one looks like p of x is x cubed, subtract 4x squared, plus 4x, subtract 16. I think this one's cute. Has 4 terms. Leading coefficient, understood to be a 1. Degree, 3. That means I should get 3 answers. 3, they call them zeros. So I'm looking for 3 zeros, guys. No graphing required at this moment. Now, if I jump into it and do as we've done in the past, you say, well, Professor, if you're looking for zeros, that means set this equals 0 and consider this. I agree 100%. Now you got to solve that. Now, the reason I brought this in, it's a polynomial function, 4 terms, degree 4, constant negative 16, leading coefficient 1, and it's in descending order. Now I'd like to know, what are my 3 zeros? Does anyone have an idea of how you approach this to find the 3 zeros? Right before the break, I gave the zeros to you. And you had to write the function the zeros came from. This one, no, I gave the function to you first. Now you got to find the zeros. Any ideas of how to find the zeros on this one? I need 3 zeros. Is it negative 2, comma, 5, comma, 1/2? Is it 0, comma, I, comma, negative I? I need 3. Go for it.
Would you add 16 to the other side and factor?
I would love to do that, and there's nothing wrong with that, but I will tell you ahead of time, it's going to take me in the wrong direction. But absolutely you can do it, but it's not going to take me to where I want to go. That's why I love this class. Yes?
The rate of first coefficient and second coefficient and third coefficient and the constant is same. So
Wait, hold on. You're looking at something really strange here. You're multiplying the coefficients together, like negative 4?
No, multiply the rate of.
You're adding them?
No, it's hard to explain. Can I write?
No, well, no, just tell me from there. You're doing something with those coefficients. Yeah, just to slow you down a little bit. Which may work. I don't know exactly which technique you're asking about. No, I'm looking for something that I think every student in this class has done somewhere in a math class that will help me find the 3 zeros. Go for it.
And we prove like x behind the bars, so it's going to be x squared minus 4x plus 4x minus 4.
Okay, tell me what I would do first, the way you described it. Well, what should I do? Okay, I'll do it. What do you want me to do?
Put x behind the bars.
Well, I know you're describing that behind the bars, but I don't quite understand what that means. It's something else. I think you're close. You're getting close. You're getting close to what I want. Yes?
Would you factor by grouping?
Oh. Now, tell me the grouping you have in mind.
X squared times x minus 4.
Wait.
So you're grouping,
You grouping like this?
yeah.
She's the way Professor split it up. And they call it grouping. So group it like this. She said group it in those pairs. And then ask yourself, what can I do in each group? Maybe that'll help me. And in the first group she gave me, which is a beautiful suggestion, thank you. Guys, I can pull out a common factor of x squared. They both have an x squared in them that could be taken out. And I have x subtract 4 remaining. That's just algebra 1. Down on the second grouping that she gave me, I can take out a 4 as a common factor, and now I have 4 times x minus 4. Now, can someone tell me something that really nice has happened here that I can go further. What can I do now? Yes?
I can present it in a way x minus 4 plus x squared plus 4.
Okay, x minus 4, hang on now, times x squared plus 4, it can be expressed like this.
Yep.
Guys, can I go from here to here? And if so, I need a reason, rationale why, because I think that's what he gave me. Why am I allowed to go from this step up here that she gave me earlier, the grouping, down to here? Do these two terms have that in common? Do they have an x minus 4? So it's like factoring again. You're going to take an x minus 4 out of these two terms, and x squared is the first term, 4 is the second term that's left over. You just took out a common factor. Strange common factor, but it's x subtract 4 is my common factor. Now, this is supposed to be equal to 0. All right, guys, don't be misled. This right here will not factor any further. Don't think it's x plus 2 squared. It will not factor any further. So I think I'm ready now to solve, split this up like we usually do, and consider each one of these factors equal to 0. First one's easily done. Are you kidding? One of those 3 zeros I'm expecting is 4. Immediately. This one I have not solved yet. I'll try to solve it, move the 4 over, subtract it. Now, I'm going to end up with x is equal to, since that's a small quadratic, plus minus, to ensure I get 2 answers. Square root negative 4, or plus minus what?
2i.
2i. Therefore, I have 2i, negative 2i. Please tell me at this point, do I have 3 zeros? And they asked me to find the 3 zeros of that polynomial function, and I found them. Right there. Now before I leave, well, maybe I will leave this one. They said found the zeros, and we found the zero. Okay, part 2. To sort of move me into where I gotta be when I see you guys on Monday. Next. Now when I ask you to do this. Hang on. Trying to find the nicest one I brought in here. Oh, here it is. Okay. Sketch. P of x equal to, and I gotta be very careful on this one. It's written like that. I want to see a sketch of it. Now I need some input from students. They want to see a graph. Show me what that looks like on a graph. As a graph. Any ideas of what you might do? Bella, I think I saw your hand going up.
Yeah. There's 3 x-intercepts, so we can plot those.
She says, Professor, the way they gave this one to me, if you go ahead and say, do this business over here, find the zeros, this one's very easily done because they've already factored for you. She says, go ahead and do this. I agree 100%. Split this up. We'll get this. I'll do it fairly quickly because this part's easily seen, I think. Guys, are those the 3 zeros? Easily done. I got the 3 zeros. But the question is, sketch. I want to see a graph of this. Now give me more ideas before I jump to a grid and try to see what this thing looks like as a graph. I'll tell you ahead of time, it's not going to be a parabola. Yes?
Do we go by the degree to know how many curves?
Now tell me I didn't expand it out for you. Let me go ahead and expand it out because Shane has an idea here. She said, Professor, you could leave the x out front let's expand this thing out. If I multiply these two together by, some of you guys call it FOIL. If I multiply these two together, that's x squared subtract x. I think subtract 30. Is it? And then multiply it out, distributive property, distribute the x. And guys, I think you end up with, if I have no mistake, that. That true? Is this one a cubic?
Yes.
The degree is 3. Which says I should have got 3 zeros, and with Bella's help, we got 3 zeros. But I still don't have a sketch. I need a sketch now. So if I go to my grid, and try to get some help here, and Shane, I think you were telling me something that may help. She says, Professor, those zeros that you have up here, when you get to the grid, those are the x-intercepts. So we got what? 0, -5, and 6 are my x-intercepts. So I've got 0 here. I'll just jump down here to save a little time. This is -5. You go up here and say this is 6. And mark those right down. The graph that I'm looking for must go through or touch those x-intercepts. Those are my zeros. Now if you want the y-intercept, I think we sort of lucked out here. What is my y-intercept? And to find it, you replace x's by 0. How does I replace the x's by 0 either here or here? What will I end up with? Is it going to be 0?
Yeah.
Which we have already. Now I'd like to know what the graph looks like. Thank you. That's exactly what I wanted to say, do today with you guys. He says, Professor, I remember from Monday you did a beautiful sign analysis problem. You used sign analysis to get the sketch. Well, here we go. So we'll try test number here, test number here, test number here, test number here. Now watch carefully. This is chapter 3, so I'm moving a little further this time. My test numbers, I'm going to choose those guys. We'll try maybe a -6, maybe a -1 here. Let's try maybe 2 here. Let's try an 8 here. We all know sign analysis. And where am I going to place them? Right here. In that factored form. I'm trying -6 first, guys. -6. We'll replace x by -6. I know it's negative. -6 plus 5 is negative. -6 subtract 6, -12. Are they all negative? I did it quickly. Sign analysis, they're all negative. Which means from Monday, like he's trying to get me to do here, where's the graph located? Below. I'll make it look something like that. A little curve to it. Not linear, not a straight line. In between, I'm trying -1. Up here goes my sign analysis. Replace x by -1, of course it's negative. -1 plus 5, positive. -1 subtract 6, I think it's a -7. Please help me out. Is that a positive?
Yeah.
I did it quickly. Which means now, in that interval, the graph should be above. That means pick it up, make this above the x-axis. And we'll make mine look something like that. Rough sketch. Next interval, I'm trying a 2. Sign analysis. Put a 2 in there, replace x by 2, of course that's positive. 2 plus 5, positive. 2 subtract 6, negative. I've done that correctly. Which means from 0 to 6, the graph is located, what? Below? Here we go. Now how far it drops down, I don't know, you don't know. If anyone can tell me what that point is right there, you're finished with the course. You're done. I'll post the aid for the course for you. If anyone can tell me what that point is right there. Nah. Okay. Now, one more test. I'm testing 8. Here we go in the red here. Replace x by 8, positive. 8 plus 5, that's a positive 13. 8 subtract 6, another positive. All together is positive, which means out here, my graph is gonna finally go above the x-axis, and it's positive, and do something like that. Would you guys agree that that's a quick shape of this graph? Absolutely. That's a quick shape of what the graph looks like. I did it by sign analysis. Now, here goes. Let's see how much time I got here. I've done a lot of work tonight, guys. You've done a lot of work with me on all this. Let me use the black marker. Let's go back to the original function. It's graphed. Now tell me what you think the domain is on that blue graph. Except from left to right. Except everything. Now, I could not, yes I could. What's the range, the up and down? Is that also negative infinity, it's dropping down forever, rising forever? Now please tell me, I told you I'm trying to connect all this math together. Is there on that blue graph a local maximum somewhere? I see where it sure is, it's right in here somewhere. Now, do I know what its value is? Not until I would do calculus on the board, and you would not know what I was doing to begin with. But I can find it. So we cannot find it here. Is there a local min? Right here. I have no idea what it is. Unless Mr. Park, Susan, myself, we do on the board maybe a little calculus, and we probably could find, is that right, Mr. Park? We could find that minimum value right there. Right now, we can't do it. But there is one there, a minimum, a local min, and a local max. Is there an absolute max? Nope. Absolute min? No. There's the graph. There's a professor like this, that looks so easy. And sign analysis, I love sign analysis, don't you? Now, if we do all the problems coming up by this process, which I love, I'm very, very patient. Patient. All the way through and showed you all the signs, just showed you everything, didn't I? Very patient. If we do the rest of the course with sign analysis, we will not complete the course. It takes a little time, doesn't it? It takes a little time to show sign analysis. So what I want to do, that chapter 3 brings in to us, for us, this graph. Please tell me, look at the first term. The first term, not just the leading coefficient. The leading coefficient is 1. But the first term of this trinomial. It must be a trinomial. I know it's 1, leading coefficient. X cubed. Please remind me on the handout I gave you with the parent functions. Please, if I say class, can you remind me what just the x cubed graph from that handout look like? Yes, sir, Professor, no problem. It looked like this. So what, x cubed, let's step back. Oh, I'm good. Is that what it looked like? Now, is there some connection with my x cubed graph and my blue graph? They have something in common which is going to help me maybe avoid using sign analysis, even though I love it. Does anyone see anything going on here between the blue graph and the black graph? Well, look at it closely. They have something in common.
Original symmetry?
No. Oh, yeah, maybe it's symmetry, maybe, no, something else.
Negative infinity?
Come again.
Same end behavior?
Say it again.
The same end behavior?
Oh, wait, so you're saying out on the ends. Okay, out on the ends of the blue and the black. Okay, out on the end of the blue, is the blue graph going up forever?
Yeah.
He says, Professor, now look at the black graph. Is it out on the end doing the same thing?
Yeah.
They call that end behavior. The graphs behave the same way on the ends. By the way, on the other end, over here. The blue graph is dropping forever. Was the parent graph, the x cubed graph, was it also dropping forever? So they're behaving the same way out on the ends. Now, how am I gonna write that? Here we go. This is called end behavior. How about 5 minutes here. End behavior. They're behaving the same way. I don't want to scare you. But the way we show that, without actually seeing the graph, we do it this way. As x is getting large, I'd like to know what is my function doing, which should be the same as my parent graph. What's it doing? So guys, that means x gets large. X is approaching infinity. I stop at 6. No, it says keep going. Keep going. And what is my blue graph doing as I've stretched it? I'm going this way, but it's going up. How would you describe what is its behavior out there?
Rising.
Is it still going up and up and up, no matter how far out you go? Described as P of x is approaching what? Infinity. It's rising. Now, what's my graph doing on the other end? I should have used the blue, guys. Oh, you know what? The black one also. Oh, here we go. As x is approaching negative infinity. That's what it's written. Now you're on this side. What are my graphs doing? Either the parent graph or the blue graph or the black graph. What are both of them doing as I walk out this way forever? What are they doing? Are they dropping down forever?
Yeah.
Described as P of x is approaching negative infinity. Thank you so much. So, see, that end behavior, they're behaving the same way out on the ends. Now, they may not be behaving the same way in the middle, certainly they're not. Look at the blue graph. It's doing that crazy stuff. My parent graph's not doing that crazy stuff in between. It's out here on the ends. They're behaving the same way. Now, to close down before that little short quiz takes place, why not? Let's rewrite what I have up there, but let's use some calc notation. I'm going to just go ahead and throw it at you. In calculus, they'll be saying the same thing we're saying right now, but they like to write like this. As x is approaching infinity, my graph is also approaching infinity. So that means as I walk out this way forever, that's this part on the x-axis, my function, the y's, are also in this case rising. So it's increasing here, increasing here. Is that true, guys? The way the writing calculus is, the limit, and they abbreviate limit as L-I-M, L-I-M-I-T, as x gets large of this function, it also gets large. L-I-M, abbreviated for limit. Underneath there, you have got to tell me, what are you approaching for the x? We're approaching infinity for the x of my function. And what's my function doing? It's also rising through infinity. The other one, limit, as x is approaching negative infinity of my function. That's now you're on this side here, guys, so x is going way beyond -5. That's the x, keeps going, keeps going. That's what this means. X is going in that direction. What's my function doing? I think the function out there was what, dropping?
Negative.
Negative infinity. And that's the way it looks if you use calculus. I'll get to do that calculation more with you on Monday. I thought at least we'd introduce it to you. Mr. Park, is that correct? That's the way we write in calculus. Wow, what a night. Do we meet tomorrow?
No.
Oh. All right. Okay. Now, let's have everything put away. Score these papers.